Hi, I'm Jaap Verbaas, the VP Exploration of gocobalt, trading on the Canadian Securities Exchange as GOCO, G-O-C-O, and I'm very excited to share some of our work on the Monster Copper Cobalt project in Yukon. The Monster property is located within the Wernicke breccia, a large IOCG system in northern Canada. During my PhD, I studied the Wernicke breccia and found further evidence that these were connected to the prolific Gawler craton when they formed. And the Gawler craton holds several IOCG deposits, such as the Olympic Dam deposit. In Canada, the Wernicke breccia extend from the Ogilvie to the Wernicke Mountains over a distance of more than 300 kilometers. Most of the money in past exploration has gone into the Wernicke Mountains. However, the Wernicke Mountains are currently located within the Peel watershed, and exploration has come to a complete halt. However, the Ogilvie Mountains are relatively unexplored, and gocobalt recognized this opportunity and that there were a large area of the Ogilvie Mountains is outside of the Peel watershed. So gocobalt acquired the Monster property in 2017. The Monster property is 63.5 square kilometers, so it's a very large area to explore. The property occurs over a distance of 18 kilometers, and past exploration has recognized approximately 14 mineralized showings. These showings contain copper and cobalt, with grades up to 2.8% cobalt and 45% copper. We started our work in 2018 with a spectral analysis. Spectral analysis uses satellite data such as Landsat and Aster in order to say something about the mineralogy on the claim. And of course, in an area like the Yukon, where the access is technical and expensive and the field seasons are short, spectral analysis adds a lot of valuable data to the claim. And by generating targets, we've been able to find several copper showings, and even better is that most of these spectral targets generated are still untested. We also conducted a soil sampling survey during the 2018 program. We sampled a total of about 800 samples, about 200 samples in the valley in the east and about 600 samples in this valley here. Elevated cobalt concentrations are here shown by blue dots. These are over the 80th percentile in cobalt. And you can see a large cluster of samples here and a large cluster here. We believe that these samples were originally continuous, but that they are offset by a fault that runs through the valley. We can also see this in our radiometric survey, and we have a broad zone of low total counts showing up on this ridge here. That appears to continue into the zone of elevated soils, and we think this continues to the northwest. So we appear to have a totally unexplored target here. We have numerous surface showings on the property, but we've started thinking about these more as general areas that we're interested in, and especially after receiving the data from our 2018 program. And these general areas include, for example, the Bloom area, which contains showings that have high-grade cobalt and copper, and in particular one zone of strata-bound cobalt mineralization that occurs over 150 meters. Several of these zones are bordered by shallow magnetic anomalies, and there are more magnetic anomalies here to test in our coming programs. The second area is the arena, which contains copper and cobalt showings, and one pure bornite vein occurs here that's yielded a historical grab sample of 45% copper. And interestingly, in the arena is that radiometric data shows kilometer scale zonation of the alteration in this area. And it really appears as a bullseye on the radiometric map. Our recent magnetic survey identified several shallow magnetic anomalies. And these shallow magnetic anomalies, especially in the Bloom target, are associated with surface mineralization. So surface mineralization straddles the magnetic anomalies. We're very excited by this because we have numerous shallow magnetic anomalies on the property, and most of them are untested. We further have 3 large magnetic anomalies on the property, all of which are about 1.5 to 2 kilometers in diameter. The easternmost anomaly is only about 100 meters from the surface and represents an easy target for a future drilling program. The other anomalies are slightly deeper, but still at mineable depth. During our future exploration, we will test the shallow anomalies first to learn how the magnetics relate to mineralization and to identify possible mineral zonation. We will test the anomalies by a combination of drilling, soil sampling, and potentially ground-based geophysics. We are further planning a deeply penetrating geophysical survey, such as airborne EM or magnetotellurics. And this geophysical survey will be able to visualize different resistivities in rock, which will allow us to better target our future drill holes. In conclusion, the monster property is hosted within the Wernicke breccia and is an IOCG prospect. Our spectral analysis has shown that targets locally coincide with copper surface mineralization, and many more targets remain untested. Geochemistry has shown anomalous cobalt and copper in soil, and this is corroborated by our radiometric data. Our magnetic data has shown numerous shallow magnetic anomalies, some of which coincide with surface mineralization, and 3 very large magnetic anomalies, one of which is very shallow to the surface. Our future exploration includes a combination of shallow drilling, soil grids, and either deeply penetrating EM or MT in order to visualize rocks of different resistivities. As you can see, we've done a considerable amount of work to advance the Monster Copper Cobalt project, and I hope you join us as we develop it further.